Hey developers, welcome to Discovery. Today, we're bringing you the hottest open source projects trending on GitHub, so you don't miss any tech developments worth your attention.
Today, we're taking a deep dive into a trending project on GitHub, RuView, a mind-bending tool that turns standard Wi-Fi signals into a system for real-time human pose estimation. This project is gaining thousands of stars because it can monitor vital signs and detect presence, all without a single camera, raising huge implications for privacy-focused smart home and healthcare applications. What if you could see through walls, not with a futuristic gadget from a sci-fi movie, but with the Wi-Fi you already have? A new open-source project claims to do just that. It's designed to turn simple radio waves into a powerful tool for understanding human presence, posture, and even vital signs, all without a single camera. The project is called RuView, also known as Wi-Fi Dense Pose, from the organization ruvnet. It's an ambitious system that uses commodity Wi-Fi signals to perform real-time human sensing. This isn't just a niche academic idea. The project has gained incredible traction. It's accumulated over 25,000 stars on GitHub, with an astonishing 4,400 of those added in just one day. This rapid surge in interest suggests it's tapping into a major need within the developer community. So, what is the core problem RuView is trying to solve? It's all about monitoring human activity in situations where cameras are impractical or simply not allowed. Think about monitoring an elderly person for falls without invading their privacy, or managing office space usage anonymously. It could even be used to search for survivors after a building collapse. Previous solutions usually relied on cameras, which come with serious privacy risks, or wearable devices, which require people to actively use them. RuView's unique angle is to repurpose the invisible sea of Wi-Fi signals that are already all around us. It analyzes how these signals are disturbed by human movement to build a picture of what's happening in a room. So, how does this technology actually work? The system's architecture operates a lot like echolocation, but for radio waves. It analyzes disturbances in what's called the Wi-Fi Channel State Information, or CSI. CSI provides detailed data about a signal's path from a transmitter to a receiver. While a standard laptop can perform coarse presence detection, the full system uses a mesh of low-cost ESP32 devices to capture much higher fidelity data. Two key technologies make this possible. The first is an AI-driven signal processing engine called ruvector. Instead of using rigid, hand-tuned filters, it uses attention mechanisms and graph algorithms to intelligently separate signal changes caused by humans from general background noise. This allows it to adapt to any room. The second key technology is a technique called multistatic sensing. By coordinating multiple ESP32 nodes, the system creates numerous overlapping signal paths. An AI model then fuses the data from these different viewpoints, resolving blind spots and creating a full 360-degree picture. It's a lot like how having two ears provides better spatial hearing than just one. The potential applications are extensive and diverse. In healthcare, it could enable privacy-first fall detection and non-contact breathing monitoring for patients in elder care facilities. For smart buildings, it could anonymously track room occupancy to optimize heating and lighting, saving energy. But perhaps the most compelling use case is its disaster response module, called Wi-Fi Mat. It's designed to detect the faint breathing signals of survivors trapped under rubble, where cameras and thermal sensors would be useless. For developers wanting to experiment, getting started with basic tests is simple, requiring just a Docker command. However, unlocking its advanced capabilities, like pose estimation, requires setting up a mesh of specialized ESP32S3 hardware. With all this buzz, the community reception has been sharply divided. On one hand, developers are praising the innovative privacy-first concept. On the other hand, there is significant skepticism. Discussions on Hacker News and GitHub show concern that the project may be an AI-generated prototype with more marketing than substance. These critics point to a lack of real-world video demonstrations and incomplete documentation as major reasons for their caution. Beyond the community's skepticism, the project faces some very practical challenges. Its most powerful features are tied to specific, CSI-capable hardware, and a multi-node setup, which complicates deployment for the average user. And as a radio frequency technology, its performance in electromagnetically noisy environments remains a big question mark. Furthermore, with over 60 specialized edge modules, the project's vast scope creates a risk of feature creep. This could undermine the stability of its core functions and overwhelm new users just trying to get started. In the end, RuView presents a fascinating, if controversial, vision for the future of sensing. It aims to transform the ambient radio waves all around us into a powerful and privacy-aware perception layer. Whether this project fully delivers on its promises or not, it forces us to reconsider the hidden potential within our existing wireless infrastructure.
That's all for today's Devcovery. We hope these GitHub trending projects spark some inspiration for your development work. You can find all the repos mentioned in the description below. If you enjoyed this episode, don't forget to subscribe to our channel. See you tomorrow at the same time.